OK，那个考试分数派回来了，拿到多少 ？Let me know your marks. Excuse me. So how's the exam? Marks, Ariel, what did you get? The rest? Ashley, Samuel, Wensing. How's your exam? No response. $15 over. Okay. You let me know your marks so that I can roughly know like how to position myself and so that I know where to help you. Okay, it's helping you also. It's helping you also. You let me know like what did you get? Exam. Okay, because I want to know roughly what is the current understanding. Okay, so I can better position myself and I know what is the where is the problem. Okay, so you let me know your marks and I know. All right, yeah, I got, thank you. Okay. Okay. So today we continue the last part of electromagnetism. Now, I want to talk about transformer today. We finish this and then we can go to the next chapter, which is electronics and also radioactivity, all that. Again, a reminder again, if your teacher said that the UEC is going to come out, let me know early so we can go through it. Okay. If not, then we'll stick to the SPM syllabus. Right, transformer. Now, we close this window. Okay, yeah, got it. Wensing, sorry. Okay, now, so guys, transformer, what is it? It is used to increase or decrease voltage. Increase 我们叫 step up, decrease step down voltage. Why? 为什么我们要有 transformer? 如果你没有 transformer, 你没有的 transmit electricity. Electricity comes from the power station, right? You have many power stations, hydro, solar, nuclear, anything. You produce electricity from there. You need to transmit, send it to all parts of the world. Without a transformer, that will become impossible. Okay, so what is it? It is used to increase and decrease. Now, how is it related to the transmission? Okay, that's Samuel. Yeah, okay, got it. All right, thank you. Okay, so now transformer, as simple as it sounds, it is in every devices. You can find it in every devices. Let's say 你家的 microwave oven，let's say 它需要需要2000 voltage 来 operate，然后你的手机 let's say 它需要4V 来 operate，可是你的 oven 跟你的手机插去同样的 socket， 那个 socket 给你多少 volt？ 家里面的那个 socket 240 volt， 那个是 standard。 Okay, so in Malaysia all the socket, the 3-pin socket is 240 volt。 可是如果你的 microwave oven 需要2000 volt， 为什么你只需要插在一个240 volt 你都可以 operate？ 同样的，你的电话只需要4 volt， 你插进去那个240，为什么它不会 damage 你的电话 ？OK， 这边就是 that's why 我们需要有 transformer。transformer 如果 for microwave oven 你要2000 volt， then 里面在 microwave oven 里面的 circuit 它已经自己本身有一个 transformer 了。当你插去那个插头，它会 increase 那个240 volt 去2000 volt， then 它可以 operate normally。同样的电话 a little bit small transformer, and then you can decrease, you can step down the current so that it is suitable for your device. Okay, now how does it look like? Transformer, it looks like there are 2 coils. Primary coil 是有电的 ，OK， 然后它是一定要 AC current。什么是 AC current？ Alternating， 意思说它的 value fluctuate。在前一个 class 我们已经看了 generator 对吗？你从 generator 我们 produce electricity。How is the electricity being produced? If I draw a graph, this is the EMF and this is the time. It looks like this. The graph is like this. This is you get from the AC generator. So when the coil inside rotate, that's induction, right? So current is produced and the value of the current increases to the peak, drops back to 0, and then now it goes the other end, the negative, which means that the current now is moving opposite direction. Again, it increases and then drop. This is AC current. DC current, the graph is flat, straight, because the value doesn't change. Now, transformer, here in the primary coil, the primary circuit, there must be a AC current. So current is flowing in this coil. This is wires making many turns. Okay, now current has got magnetic field. And when current changes direction, what happens to the magnetic field? The magnetic field will also changes. It flips every few seconds. Okay, so when current changes, it produces a change in magnetic flux. Very important keyword, change in magnetic flux. Change in 我直接叫它 change in flux. Flux 意思说就是那个 magnetic field 的 line. Okay, now, and then on the other end, we must have a secondary circuit also. And secondary circuit also made in many turns. And this secondary circuit usually is used to power the device. So let's say we have a resistor here. Okay, now what happened is that the magnetic field in the first coil will induce current in itself, right? Primary coil, 它的 magnetic field change 的时候，当你有 change in flux, then induce current 会 produce。它 produce 在哪里 ？produce 在 the primary coil itself. There is an induced current. At the same time, this field, right, it extends further out until it goes around this secondary coil. Meaning that these two are the primary and the secondary coil, they are placed very, very near to each other so that the magnetic field can reach the secondary coil. Okay, now what happened here is that again, induced current is produced, but this time it is produced on the secondary coil. Now, The induced current value, the value of the induced current, it is governed by this formula here. Okay, the change, okay, I write this as EMF, E, equals to negative D magnetic, the change in magnetic flux, this one, divided by time, dt. Okay, negative D change in magnetic flux over dt. Now, this symbol means the magnetic flux. Okay, this formula simply means if you have a greater change in magnetic flux, the faster the speed, if it changes very fast, then the EMF produced will be very great. Okay, and if it changes very slow, then the EMF produced is only a little bit. So it is proportional to the relative speed of the change. Okay, so this is what the equation means. Now, this is only for one coil. One coil. If I want to calculate the total EMF produced, then I will times into the total number of coils. So let's say what a primary will you this number of coil NP. N stands for number of coil, P is the primary, okay, primary circuit. Number of coil 我乘进去我的 E, which is for one coil 的 EMF, 我就拿到 total voltage. So NP times E, I get VP. That is the voltage in the primary circuit. Okay, equals to the number of turns times by the magnitude of the induced current, the induced EMF. Now, same on the secondary coil, 第二个 coil, 一样的 magnitude of induced current 会 produce. Now, 可能你可以 argue 你讲 OK 为什么会一样呢？因为这个你离这一个越远，它的 magnetic field 会越弱，对吗？ Technically speaking, yes. But here we assume that they are almost the same. Because they are very close, I can just take same value. So meaning that here, if you want to calculate the voltage on the secondary circuit, it is the same as number of turns in the secondary coil times into the induced EMF. So we got these two formula here. Okay. Now, to find it, I can divide this. I want to see the relation between these two. I take VS divided by VP. So equals to NSE divided by NPE. This one cancel, then I get VS, VP equals to NS over NP. This formula, please remember, you're going to need this. This is very important ratio, NS over NP. This is, we call it the turn ratio. Okay, the number of turn in the secondary divided by the number of turn in the primary. Okay, let's say you want to power your microwave at 2000 volt. You put it where? You put it in the secondary circuit, right? Now, in the primary circuit is the one that you put in the socket, right? So that is 240. Okay, let's just take 200 for easy calculation. Okay, 200. So this voltage I need is 10 times more greater than this one, 200. Okay, so if I want to produce a voltage that is 10 times more, I want to magnify to 10 times. That means that I need 10 extra turn in the secondary coil. Okay, so if I put, let's say this is 10, 50, okay, this is 50 turns, then this must be 500, 10 times, okay, it should be 10 times. Then only it will produce the voltage I need. Similarly, if you want to charge your phone, 4 volt, what happened? You want to decrease, because initially it's 200. You want to decrease down to 4 volt. Then you use what? You use smaller turns. Okay, smaller turns. Now, if NS, the secondary, is more than NP, then meaning that I'm increasing the voltage. 如果你的 secondary, the coil 多过 primary, then 你会拿到比较大的 voltage on the secondary. You are stepping up, increasing, so we call it a step up transformer. 然后如果你的 NS 是小过 NP, then you are You're using a step down transformer. So two types in general, step up and step down. Okay, why do we need a transformer? Why? I can just connect the wire like this one, like this. If I take the power supply like this, I can just connect like this. If you connect like this, yes, you can, but the voltage is going to be the same. So this is 240 volt, then here is also 240 volt. That's why you use a transformer. We get more different values. We can adjust it. Okay, we can adjust it. Now, using this one, right, the transformer, because the magnetic field 从第一个 coil 的那个 magnetic field 它是it goes everywhere, right? It goes everywhere. Magnetic field around it, around the coil. So there's some magnetic field that is not reaching the other coil. Then this will cause magnetic field leakage. Okay, there's a leakage, meaning that there's a waste of magnetic field, because here the magnetic field on one side is not reaching the other side. Only a little bit, small portion of it reaches the secondary coil. So what we do is we use what? We use a ferromagnetic material. What is a ferromagnetic? Like iron. Iron, so you can see a transformer, usually they put like a block of iron core, and then they put a wire like this. The primary goes around this, secondary goes here. Why do I need the iron like this? Why? Because the iron, ferromagnetic material, it has a unique property. 它可以做什么？它可以把那个 magnetic field channel 去对面那边。这个 ion 它可以好像 absorb 那个 magnetic field。This ion can keep the magnetic field inside it, and then they pass the magnetic field to the other coil. So what they do is it can maximize the flux reaching the other end. So meaning that it can minimize the leakage of magnetic field. This is why usually in a transformer you see this iron. Okay, this is iron, like they use iron block. So what happens is that the magnetic field will flow inside the iron, across it, like this. Like this. Okay, in other words, I can say that this core increases the magnetic flux, increases the magnetic field density. Magnetic field density. Okay, so to improve the efficiency of the transformer. Now, again, one more thing. Here on the primary coil, it must be AC. Why? Why cannot be DC? Because DC, there's no change, right? The current is the same. Fixed current, fixed voltage, 6 volt and it's 6 volt. If it doesn't change, meaning that the magnetic field doesn't change. So if the magnetic field doesn't change, then there's no induced current produced. Then the transformer is meaningless. Okay, so you must use a AC current. Okay, now that's why you see some of the devices like wireless charging. Recently, you see a lot of wireless charging phone, right? So that is the working principle is based on transformer also, right? Your wireless phone, okay, let's say this is your phone, right? Inside got a transformer, got a secondary coil, You put it on the charger, wireless, right? You put it on it. The first coil is under the charger, okay? So how they charge? Same principle, like the transformer. The magnetic field pass through the secondary coil in the phone. So you charge it. That's wireless charging. Okay. Now, next one. Okay, now we look at power. Now we talk about power. Power. Okay, let me go to the next slide first. Okay, I erase this and then I go to the next slide. Okay. You should be able to see a drawing, a few drawings. Now, look at the drawing at the bottom. Let's say I want to power a light bulb here on the right. Let's say it needs 100 volt. Okay. Now, there's a power supply very, very far away, and it supplies 100 volt also. How do I transfer the electricity from here to here? I can just take a cable like this. Can I? Just connect the cable like this. If I connect the cable like this, straight away, yes, I get the current, but what happened is that when the current reaches here, then many power would have already lost. Why? Because wire has got resistance, okay, has got resistance. When current flows through long distance of wire, then it will produce heating. It will heat up the wire. It will heat up the wire. What happens is that there will be energy loss. Okay, by the time the current reaches there, then it becomes very small already. Okay, so it's not practical, it's not efficient, right? And if you see, 如果你看那种 generator 的 wire 很大个，像 it's very thick, it's like the size of your head. Okay, it's very thick wire. All the power cables. So resistance will be very, very high. Okay, so that's why we use a transformer for a transmission of electricity. Now look at the diagram on top, the first one. Let's say here I put two transformer. Okay, this is the one that I want to power, right? 100 volt, and this is supplying 100 volt. Okay, here I join the wire like this. By using two transformer, first I step up. 首先在左手边这边，我的 generator produce 100 volt 咯， then 我先 step up 它先 ，step up 它去 let's say 1000 volt using the first transformer, and then this current is being transmitted all the way to the device, and then being stepped down again, down to 100, like this. This is better than the bottom one. Okay, let's see why. Now, let me erase this first. 这边 let's look at the right. If I ask you, what is the current flowing in this circuit? I. Okay, it's easy to find it because you only need to know what is the resistance of the bulb. You already got the voltage of the bulb, right? So you just need to know the resistance. Let's say the resistance of the bulb is 100 ohm. So we can do simple V equals to IR Ohm's law calculation. So I equals to V over R. 100 除以100. So that's 1 ampere. Okay, so 1 ampere is flowing in this circuit. Now, if this circuit is 1 ampere, then what is the current in this circuit? I. How do we find it? Okay. To find this current, can we use Ohm's law, VIR? Cannot, right? Because we don't have the resistance. So to find this current, we use energy conservation theory. We simply use the conservation of energy. We know that energy change from one form to another form, and the energy is conserved, right? If it's 100 joule here, then it's 100 joule here. 100 joule loss, 100 joule gain. We use that one, but okay, but energy in terms of instead of energy, right? We use power. We use energy per second. Energy per second. That is power. Okay, and power equals to what? Power equals to IV. 意思是说 power coming in 跟 power coming out 是一样的，所以我可以写 P in equals to P out. Again, you need to remember this one. 这一个我的 assumption 是什么？我的 assumption 是我的 transformer 是 ideal. Ideal transformer, what does it mean by ideal transformer? Ideal 意思是说 它没有 loss， 我们 assume 它的 efficiency 是100%， is the best 100%。There's no loss of energy, but in reality, there's no such thing. Okay, there's always loss of energy. But for the sake of easy calculation, we assume that it is ideal transformer. Because in real life, right, if you look at transformer in real life, there is many power loss due to what? Due to what? First thing, this changing flux, the magnetic flux that travels in the iron block, because it keeps changing, right? So it will produce what we call as a hysteresis loss. That is heat. The loss of energy due to heat. In short, meaning that it will heat up lah. It will heat up the iron and causes loss. That's the first. Second is that this changing magnetic flux, it will induce current in the iron also. 它不只是 induce current 在这个 secondary coil， 它同时它会 induce current 在这个 iron block， 那个我们叫它 eddy current。OK， 什么是 eddy current？ eddy current 是 current that is induced in the iron core. And if you look at the surface of the iron, right? So say this is the surface of the iron. Eddy current is like swirling current, like this. It's like circular and closed loop. This is how we draw it. Because the iron itself is also a conductor, what? Iron 自己也是可以 conduct electricity. 所以你的 changing electric flux 都会 induce current 在那个 iron core, right? So is this good or bad? This eddy current. This eddy current will heat up further. It will heat up the iron core and further causes heating and more power loss. Okay. Not only that, besides that, you have flux leakage some more. Okay, even though you use the iron block, doesn't mean that you can get 100% of the flux to the other side. There's still some leakage, and this leakage causes more power loss. So in reality, there's many power loss, mainly due to heating. Okay, but in our calculation, we don't care about all that. We just say, okay, it's ideal. There's no loss. That's why I can write P in equals to P out. Okay, understand this. Okay, so P in 等于 P out， power 就是等于 IV 嘛，所以我可以写 I in 就是在那个 primary circuit 咯，或 IP VP 等于 IS VS primary 跟 secondary。 Okay, so 我用这个来算我的 current in the primary circuit. Okay, so you find that, you can see, okay, let's say this is 100 volt, right? This is 1000 volt. So we can find IP equals to IS VS over VP. Put in the values, all this you know, voltage, and current, and you will get this is 0.1 ampere. IP 是 0.1 here. Because the voltage is 10 times smaller, right? The current here is also 10 times smaller. So the current flowing here is 0.1 ampere. Notice that it is very, very small, right? It's very, very small. So is it good or bad? Small current 代表 less heating. Okay? Small current 代表 less heating. So 如果你直接 connect 那个 wire， 像我们刚才直接 connect 没有 transformer 的话，你的 current 是多少？ 1 ampere. Because this circuit here is 1 ampere, right? 1 ampere flow through the wire, come back. That produces a lot of heating. But with the transformer, the current flowing only 0.1. So you can minimize the power loss. That is why transformer is very, very important in the electricity transmission. Now, there's one question. 为什么当我 increase 那个 voltage OK，OK，sorry，再来，为什么当我 decrease 那个 voltage，current 会 increase？你看这边，这里的 voltage 一来是1000，对吗？我 step down 它去100，它的 current 本来是0.1，当我 step down 那个 voltage 哦，它的 current increase 去1 ampere。为什么我 step down current 会 increase？相反的，当我 step up 那个 voltage 啊，current 会 decrease。Okay, because a transformer I can increase the voltage, right? When I increase the voltage, the current will drop. Why? We want to understand that. Okay, we can see it from the mathematical point of view. Okay, you see, P in equals to P out. Okay, IP VP 等于 IS VS。这个 value 是等于这个 value， 所以如果你的 output voltage increase 的话，这样你的这个 IS 会 drop， 因为你左边跟右边一定要一样 value 嘛，所以如果你 increase 这个 VS 哦，你 IS automatically drops so that the value both sides they equal. So this is why when you increase the voltage, when you step up, the current will drop. Okay, so in all the transmission of electricity, 首先他们一 generate 了过后，他们先 step up 先，他们 step up 了，他们才 transfer， 所以它的 current 是很低，到那边它再 step down。Okay, now see, let me erase this first. This is from mathematical point of view, right? So let's understand more. Let's understand more why really when I step it up, the current will decrease. Let's focus on the concepts. Okay. Now this is the transformer. Primary coil, secondary coil. 本来这边是多少？1000 volt 对吗？这边是100 volt。OK， voltage 是什么 ？voltage 是 energy per one charge。OK，V 等于 W over Q， 这个是 energy joule， 这个是 charge coulomb。意思说，你拿一个 coulomb 的 charge。When it flows from here, this point cross the coil down here, meaning that it will lose 1000 joule of energy. I repeat, in the primary coil, this one 1000 volt, meaning that when you take 1 coulomb of charge, if it crosses this coil, then it's losing 1000 joule. Where does the energy go? The energy goes to the secondary coil, right? So if you take 1 coulomb of charge and it flow past this coil, then this coulomb of charge is going to gain how much? 100 volt, right? So it's going to gain 100 joule only. Okay. This 1 coulomb of charge is giving it 1000 joule. But this one only collect 100 joule. He said, okay, you're giving me 1000, but I'm only going to get 100. Maybe later I come back and get it again. I come multiple times. Okay, so this coulomb here, he takes 100 joule and he comes back, take another 100, take another 100. So meaning that it needs to take 10 rounds. 10次才拿到1000. Okay, so what does that tell you? Meaning that when this coulomb flow from this down to here, it already flow 10 times. Okay, because the energy loss here is 1000. This one, each coulomb get 100, so 10 times, then it gets 1000 joule from the primary circuit. When the charge flow one time, the charge on the other end flow 10 times. So current is what? Current is the flow of charge. Flow of charge. If this one flow 10 times, meaning that the current has increased. Because you get faster flow, the charge flow faster, right? So this is why from the conceptual point of view, when you step down the voltage from 1000 to 100 volt, the current will increase. Simply because the charge has to travel faster in the secondary coil. On the other side, same thing. You flip the whole thing. Here, 本来是100 volt 对吗？100 volt， 你 step up 去1000 volt。OK， 100 volt 的意思是什么？这里的 coulomb 一个 charge， 它一 flow 下来，它给100 joule。1 coulomb it gives 100 joule。这里的 charge， 它 flow 上去，它 collect 多少？1000 volt 对吗？它 collect 1000 joule。OK，this one only give 100. This one collect 1000. So meaning that you need 10 charges flow on the left side. Only the coulomb on the right side make one complete flow. The charge on the left side must flow 10 times faster. So meaning that here, the charge move slower than the charge on the primary coil. That's why the current decreases. Because current is just flow of charge. The faster the flow, the higher the current. Okay, does it make sense? Understand, huh? Right. Now, you need to also calculate the power loss. Okay, what is power loss? Power loss, P 是等于 I square R. 这一个 formula 是给你用来算 power loss. Okay, during the transmission, here 0.1 ampere. You square the current, you times by the resistance of the wire. Then you get the power loss during the transmission. If you assume an ideal transformer, then there will be no power loss. Okay, now, so this one, the I is the transmission current and the R is the resistance of the wire. So you can see from this formula, right? 你可以从这个 formula 看哦，我怎样 minimize 我的 power loss， 我 minimize 我的 I 就可以了嘛，对不对？如果 I 越小，我的 power loss 就越小。So we step up until we get small current. We can minimize the power loss. Here's the question again. 如果这样的话，这样意思说，我是不是可以一直 step up 到那个 current 很小很小很小，我的 transformer 这样就很靠近100% efficiency. Okay, if I can step up unlimited, okay, if I step up 1 million, why not 1 billion, right? So can I keep on stepping up so that I can reduce the current until very, very small? Now, you got another problem. If you keep stepping up the voltage, then the voltage becomes very, very high that it can ionize the air around it. When you have very, very high voltage, it can ionize the air around it and then causing lightning. So you see lightning everywhere. Because the voltage is so high, it can pull the charged particle away from the atom in the atmosphere. Okay, so as a result, you see lightnings. So that's why there's a limit. Okay, there's a limit. The point is there's a limit to step up the transformer. Now, in the generator, the power plant, they step up to very, very high voltage. Very, very high voltage. How high? Like a few 100,000 volt. Okay, a few 100,000 volt. Okay, so here. Now, again, the formula for power loss, P 等于 I square R 对吗？从这个 formula 越低 current 就越小 power loss。Now 可能这里也是有时候有一个 confusion 呢 because there's another formula for power loss, right? There's another formula for power. P 等于 IV， 这个是 general formula 嘛？如果我 sub V 等于 IR 进去，我就拿到 I square R。如果我 sub I 等于 V over R，then 我拿到什么 ？P 等于 V square over R。这一个 V， 这样意思说什么？这样意思说是不是那个 voltage 越小 ，power loss 就越小呢？本来我们讲 current 要小嘛，对不对？所以我们 step up 那个 voltage 嘛，所以我们可以 minimize 那个 power loss。可是你又有这一个 formula， 这样是不是代表我的 voltage 小 ？OK，sorry， 我的 voltage 大，我的 power loss 会大呢 ？OK， 这个 voltage 跟你的 transmission 的 voltage 是不同的，这个要分到很清楚。OK， 我先擦掉这个先。OK 啊，我先擦掉这个先。P 等于 I square R， 还有 P 等于 V square R。当你要算 power loss 的时候啊，我们用哪一个 formula？ 我们用这个 formula。这一个 formula 你可以用，可是你要小心你的 voltage， 因为这个 voltage 不代表那个 transmission 的 voltage。这样这个 voltage 是什么 voltage？Let's say 这里是刚刚我们讲这里是100 volt 对吗？这边是1000。这个 voltage 不是1000啊 ，OK？ 因为这个 voltage 是 voltage across resistor， 所以你要很清楚，你这个 V 是从哪里拿来的？你是从 Ohm's law 拿来的，对吗 ？V 等于 IR， 你放进那个 P 等于 IV 拿来的，所以 Ohm's law 的 calculation V 等于 IR 是这个 V 是 potential across resistor。Or I can say it is the potential drop， 就很像你一个 circuit 里面是 ，let's say 这个是6 volt， here here here， this is 2 volt 2 volt 2 volt。The 6 volt is the total potential, correct? The 2 volt, what is it? This is the potential drop. This is the potential across the resistor, 2 volt. Another one across the resistor. So the V here is actually the 2 volt, not the 6 volt. The 6 volt is the transmission voltage. Okay, it is not the potential drop. The 2 volt is the potential drop. That's why this formula, the V, is potential drop. So you have to be careful. If you put 1000, then wrong. So power loss is better if you can use this formula. It's the current. Okay, so power loss is P 等于 I square R. Okay, so 还有什么方法 reduce power loss? Reduce current. 然后 OK 怎样 reduce current? Use thicker wire. Okay, use thicker wire, and sometimes use wire made of aluminum. Okay, why aluminum? Because aluminum is a good conductor, and also aluminum is very light. Okay, so usually aluminum is used to transfer the power. They call it the power cable. Okay, so two things. Now, okay, next part. Right. Improving efficiency. Okay, there are a few ways to improve efficiency of a transformer. Let me give you all this so you can have all the notes in one place. Number one, use thick copper wire of low resistance. Okay, low resistance, why? Because we want to decrease the heating. If you have high resistance, then high heating. And sometimes we can use coolant. Use coolant to decrease the temperature of the transformer. To decrease temperature of transformer. Okay, now second, we can use laminated iron core. Laminated is like I put a coating around the core. What is the reason? We want to reduce eddy currents. Okay, eddy currents, where does it come from? From the changing magnetic flux induce the current in the core. So we want to reduce that. So we put a layer, one extra layer of coating. Actually, is a paint. It's like a paint. We call it like a type of paint. They call it the enamel paint. This paint is used for like coating surfaces that subjected to high temperature changes. Okay, usually when you have surface that exposed to high temperature changes, the surrounding, then they use this paint, because this paint can reduce the temperature variation. Okay, you can use this also. Now, same, we want to reduce, in the end, we just want to reduce heating. Okay, so the transformer actually looks like this. This is the core. They are like stacked, many layers like this. 1, 2, 3, 4, 5, 6. Okay, there are many layers. They're stacked. Each layer is laminated. Okay, each layer is laminated. Again, this laminated, it produces what? Resistance. It produces resistance to the eddy current. Resistance to eddy currents, to prevent eddy currents from forming. Okay, number 3. What else? Now, in the industry, they put it like this. They take the transformer, they change the shape. They make it like this. Instead of coiling on one side and on the other side, they coil it at the middle. This is the primary coil. 这个是primary coil. 然后它的 secondary coil, 它 coil 在它的上面，这样子。It's like the connection is like intertwined. Okay, they coil up together. One is on top of another. Why do you want to do this? Because they want to maximize the, they want to minimize flux leakage. Okay, they want to minimize flux leakage, so that most of the flux is being transmitted. So this is the changing the design. Now, one more, number 4. To improve, they use soft iron. That is easily magnetized and demagnetize. So use soft iron core. Okay, you can take this down. Ways to improve efficiency. All right, let's look at a few examples. A transformer has 400 primary turns and 1,800 secondary. The input voltage is 12, output current is 3. When connected across a resistor. Okay, write this down. NP 400 and secondary 1,800. The input voltage, so V primary is 12 and the output current IS is 3 ampere. What is the output voltage? So we can just use the formula VP equals to VS NP over NS. 12 over VS 400 1800. Okay, so VS equals to, calculate this, you get 54 volt. B, determine the input current. Okay, 找 input current 啊，所以是 IP。那我要找 IP， 我用 power in 等于 power out， 所以我这边assume 什么 ideal transformer no power loss， 所以我可以写 P 等于 IV 啊 IPVP 等于 ISVS。So I times 12 equals to 3 times 54. Then my IP would be 13.5 amps. C, what is the value of the resistor? Where is the resistor? The resistor, is it in the primary circuit or secondary circuit? You see, the input voltage is 12 and the output current is 3 amp when connected across a resistor. So meaning that this is your primary coil. Your secondary coil resistor is here. Okay, then you find the current. This is current I secondary and also voltage secondary. So be careful, don't use the wrong voltage. Okay, the resistor is on the secondary circuit. So we use ISVS. So V equals to IR. R equals to Vs over Is. (54) divided by 3. So 18 ohm. That's my answer. And the last one, how much power is dissipated? So we use P equals to I square R. Okay, I square, the current, right? Current. So 3 square times into 18. This power dissipated 是谁的？那个resistor. Okay, across the resistor. So that's why the current here, I use the I secondary, not IP, not the first, not the primary coil current. Okay, that's example 1. Example 2. An ideal 100-watt transformer has an input current of 20, output voltage of 12. Okay, let's write this down. Ideal 100-watt transformer. So the power is 100 watt. Input current, so I primary, 20 ampere. Output voltage, Vs, is 12 volt. Determine the input voltage. Since I know power in, power out, so IPVP equals to ISVS. Input voltage, so it's a VP 等于 ISVS over IP. 哎，这个我们找不到，因为我们不知道 IS 对吗？我们可以直接做这样子，我们直接拿 primary 的 power 等于 primary voltage primary， 那我就放100等于20 VP。So VP 是5 volt。B 呢 calculate the output current 一样咯，我也是用 P 等于 I secondary V secondary。So 100。8.33 ampere. And the last one, this one, how many secondary turns does the transformer have if there are 200 primary turns? Okay. NP 200. This one you calculate, you get 480 turns. Okay, example 3. Transformer has an input voltage of 120, output current of 5. The output voltage is 11.9 and the output current is 49. Okay, Vp equals to 120, 5 amps. Output voltage 11.9 and output current 49. How much power was absorbed by the primary coil? P 等于 primary V primary。那这边他没有讲 ideal transformer 对吗？如果他没有讲，这样我们就不一定可以 assume P in 等于 P out 啊。所以我们先找 primary 的 power 先。在 primary coil 里面，它 carry 的 power 5乘120， 600 watt。B 呢？ How much power was delivered by the secondary coil? So power equals to ISVS. 49 into 11.9. 583.1。看到这边不同，这个是 power secondary， 这个是 power primary， 所以不同意思说它有 power loss。What is the efficiency of the transformer? Okay, efficiency, the symbol like this, equals to output over input times 1000 times 100%. What is this? This is power. Okay, power output over power input. So 583.1 over 600. The output will be always smaller than the input. It cannot be bigger than the input. Times 100. That's 97.18% efficient. Meaning that if you have 100 watt supply to the transformer, then the transformer will convert only 97. The rest is lost. Okay. So now I'll spend a few more minutes on this and I'll show you the rest. Transmission of electricity. So this is one power plant, nuclear power plant, create electricity. Okay, there are many types of power plant. This one uses the radioactive material. I repeat, this one is a power station that uses radioactive material to generate electricity. There are many types of sources. You can use charcoal, you can use oil, you can use hydro, right? All the power stations. So the nuclear power plant, now basically all power plants, they work the same. If you look at the core component of the power plant, they got turbine and they got generator. These two must have in every power plant, most of it. Okay, so what is a turbine? Turbine is like a spinning device, 就很像那个飞机的 engine. Okay, it's the airplane engine is a turbine. So it's a rotor and then it could have many fan blades. So when the air flow through it, it will rotate. A turbine converts the kinetic, the motion of the air into rotational motion. And then you can see the turbine is always connected to the generator. There's a shaft. This shaft is connected to the generator. When the turbine rotates, it rotates the generator. And you have already learned about generator. What is inside a generator? Magnets and many coil of wire. Okay, so when the magnet rotates, then it cuts the wire, then you get electricity. Okay, so the source comes from this one. The source comes from radioactive material. So basically we use the radioactive material to heat up the water. We boil the water. Why we want to boil the water? You can see the water comes from the condenser here. Okay, we start here, condenser. Water flows from the condenser to the pump and then inside here, this heat exchanger. Now, what this heat exchanger does is that when the water flow past the heat exchanger, it gains the heat energy from the reactor. Okay, so all the heat energy from the reactor will pass to the water. And the water carries this heat energy. It becomes a steam. The water flow past the heat exchanger becomes steam. Hot gases that moves very quickly. Okay, so steam rush in the turbine. What happened? The steam rushes through the turbine blades and then it turns the turbine. When the turbine turns, the generator also rotates, electricity is produced, and that electricity is passed through a transformer first. Because the transformer wants to increase the voltage, and only it goes to the electrical grid, the pylons, okay, this one. Then it sends it to all parts of the world. The water that has changed to steam, it passes through the turbine, eventually it will come back to the condenser, and then it will cool down and condense back into liquid. And the liquid repeat the same thing. It will flow to the exchanger again, and this is like a closed loop. The cooling tower is to radiate the heat from the water. Okay, so in order for the water to condense, there must be a cooling tower, get the heat away from the water, so that get the heat away from the steam, so that the steam can condense into water. So basically, this is how the power station works. In any power station, same principle. They have turbine, they have generator, they have condenser, everything. Only what is different? Only the source is different. The source they use to generate the heat. This one, they use uranium or radioactive material to generate the heat. Sometimes they can use coal. They burn the coal to generate the heat. Okay. What else? They can use oil, biomass, okay, waste material. They can burn all that to get the heat. The purpose is to get the heat out and to heat up the water. Then the water becomes steam and drives the turbine. Okay, so in the generator that you see, like the small scale one, this is the power station, right? They produce like few hundred thousands of voltage. In a small scale one, the one that used to power the all the elevator， 你去那种 shopping mall 那种 building 全那种 elevator， 他们一定有 backup 电的嘛 ，OK？ 如果没有电，他们要有 backup，so they use a small scale generator. That small scale generator still has the same thing. They have turbine, they have turbine, they have generator. But for those, what is driving the turbine? They use car engine. OK， 他们用车的 engine 来转那个 turbine for 那种小型的 OK OK so that is how a generator works. Okay, now we look at the power transmission calculation. Okay, here let me go back to the slides. Two examples before I give you exercises. Okay, example 1. A power of 10.8 kilowatt is transmitted from a small wind power generator to a village along 4,000 meters of cables that have a total resistance of 2 ohm. The power is transmitted at a usual main supply voltage of 240. Okay, during the transmission, what is the voltage? 240. Calculate the current in the cable. Right, let's write this down. A. What is the power that I want to transmit? 10.8 kilowatt. Okay, this is the power I want to transmit. That's equals to 10800 watt. The voltage of the cable is 240 volt. And to find the current, I just use P equals to IV. Okay, I equals to P over V. 10800除以240等于45 ampere. Okay, this is the current in the cable. During the transmission, this is this much of current. The loss of power due to the heating of the cable, which formula do we use? P equals to I square R. Okay, 如果你用 P 等于 V square over R, then 你要小心这个 voltage. This is not this. Okay, so we use I square R and we find it current equals to 45 square into the resistance. Okay, so what is the resistance? 2. 4050 watt of power lost. C, percentage of power loss. Okay, we just use 4050 divided by the power. 10800 times 10, 100. That's it. Example number 2. 100 kilowatt of electrical power is to be transmitted by cable which have a total resistance of 5 ohm. Calculate the power loss due to the heating in the cable if the power is transmitted at a voltage of 这个跟这个. Okay, so this is my cable. How much power I want to transmit? 100,000 watt. What is the resistance? 5 ohm of the cable, the transmission cable, 5 ohm. And the voltage of transmission, if I'm using 2000 volt. Okay, let's do A first. I'm using 2000 volt. Then what is the power loss? P equals to I square R. Okay, so first you need to calculate the current first. Okay, get the current, right? So current V equals to IR. Can we get it from here? No, right? We get it from the power. We get it from the power. So P equals to IV. I equals to P over V. So 100千除以2000等于50 ampere. Then 50 square into 5 ohm. 12500 watt. Okay, power loss 12500. Again, remind you again, if you use P equals to V square over R, if you put, okay, let's say you put 2000 volt over 5, you get a different answer. This is wrong because of the voltage. Because current is the same, right? In the transmission cable, current is the same. So that's why I can use this I square, but not V. Okay. Last question, B. 200 kilovolt. We find the current first. So P equals to I V. I equals to P over V. 100千除以200千 0.5 ampere. Okay. 可以答案在后面呢。如果我不明白就问呢。
老师，
嗯，
我们需不需要 print 出来还是什么？
up to 你自己了，你要 print 出来做都可以，或者你自己这样子做都可以。 OK，大家我们今天先到这边先，然后我们下个星期继续了。Okay, so you can log out and I'll see you next week.